Hey, good morning or afternoon or whenever you're watching this video. Today, this video is going to be on multiplying and dividing rational expressions. So we remember rational expressions. We have a fraction, polynomial over a polynomial. It could be a monomial over a monomial. That's what some people sort of said they had some issues with. um Monomials over monomials, like something like 4x squared over 3x. We did those earlier in the year. So now what we're saying is we're going to add to it. What happens if you have adding or subtracting in that expression? And that's where we're going to have to factor. So with this, there are uh, there is a PDF of the steps. So really what my job is going to be right here is, first of all, I can't spell. Um, my job is going to be doing the examples. So when we're saying fractions, this goes back. The problem is most of you, we haven't done fractions. We use our calculators. But if you're multiplying fractions, you multiply straight across. 2 times 1 is 2. 3 times 5 is 15. You simplify your answer if you can. Dividing. If I had 2/3 divided by 1/5, what you were taught in fourth grade, fifth grade, sixth grade, you keep the first fraction the same. Division becomes multiplication, and you multiply by the reciprocal of the second fraction. So now your division problem is 2/3 times 5 over 1, straight across 10 over 3. Okay, so what you can see sort of in your notes is when we're multiplying and dividing, we're really just simplifying. If there's division, flip the second fraction. Then, if you have monomials, no adding or subtracting, you just go straight across. We did those earlier this year, and I'm going to add those in as good review, ACT types of questions. If we have adding and subtracting, we're going to factor. Then we cross off any common factor, one top with one bottom, anywhere. Once you're done with crossing off common factors, whatever is left is your answer. So I'm going to start with monomials. So we would say in your first delta math questions will be monomials. So, and this is probably harder than what they're asking. If I gave you 5x squared y cubed over 3x y to the fourth times 27x to the fifth over 15x to the fourth y. You can't factor because there's no adding and subtracting. So we're going to go straight across, straight across. Multiply your numbers, add your exponents. You should remember that. So 5 times 27 is, I think, 135. X2, X5 is X7. I got Y3. On the bottom, 3 times 15 is 45. 4 X's, 5 Y's. Now what do I do with that? I'm going to divide my numbers, subtract my exponents. So 135 divided by 45 is 3. 7 minus 4 gives me 3 X's. 3 minus 5 is negative 2. So since that's negative, it goes on the bottom. So again, that is review. If it would have been divided by, you would have flipped that first and then multiplied. So any division problem becomes a multiplication problem. So now, new problems. New problems are going to be when you have polynomials. So, question like this. I'm asked to multiply that. Okay, you don't actually multiply. What you're doing is factoring. And really, if you think, this is all one thing. Okay, so I'm going to factor this first. Now, the factoring got a lot, I think, with the first assignment. You have to remember greatest common factor. What's the biggest number that goes into 4 and 4? 4. You have 2x and 1x. You can take 1 out. If you take 4x out of 4x squared, you're left with 1x. 4x divided by 4x is 1. Now we factor this. Well, this is regular old factoring. Two numbers that multiply to give you 3, subtract to give you 2, you'd have that. Now we're going to go to this. It's on the top. Factor. Two numbers that multiply to give you 6, subtract to give you 1, are 3 and 2. So I'd have 3, 2, larger number gets the sign of the middle since that's minus. And then 4x doesn't factor. So 4x stays on the bottom. So now, once you're done factoring, is there or are there any common factors? Top with bottom. Same thing being multiplied. Top with bottom. Same thing being multiplied. 4x. So what is my answer? I'm left with x minus 2 over nothing. You could put over 1. But really, that big problem is just x minus 2. Okay? So I'm going to do a couple more just to give you an idea. Just think you're never multiplying. So x squared minus x minus 2 over 3x squared. And then let's say 3x minus 12, x squared minus 6x plus 8. Okay, so I'm going to factor the top because really this is just one big top and bottom. Everything gets factored. Two things I multiply to give me 2 that subtract to give me 1 are 2 and 1 minus 2 plus 1. 3x squared doesn't factor, so it stays 3x squared. 3x minus 12. And if you can't do this, it's greatest common factor. What's the biggest number that goes into 3 and 12? 3. Take that out and think, either what did you multiply 3 by to get 12 or take 12 divided by 3. Then the last one, x squared minus 6x plus 8. Two numbers that multiply to give you 8 that add to give you 6 are 4 and 2, plus sign, same signs, whatever the middle is. Now, is there anything that's common? You have an x minus 2, you have an x minus 4, and you do have a 3 being multiplied. So what's left on the top? X plus 1. What's left on the bottom? X squared. You can't cross out that x with that because that's being added to 1. The only way you could cross So let's do a division. So the only thing that division is different. So I got 2x over 3x minus 12 divided by x squared minus 2x over x squared minus 6x plus 8. Okay? What you have to remember, which is on the notes, if you have division, this needs flip. So that becomes the top now. That becomes the bottom. That stays. Okay? Now it's a multiplication problem. Factor. You can't factor 2x. 2x stays. 3x minus 12. Take a 3 out. Greatest common factor. X minus 4. This is on the top. Two numbers that multiply to give you 8. That add to give you 6 are 4 and 2. The factoring, you guys should all be good at. The greatest common factor is the thing I think a lot of people are sort of forget. If you can't do regular factoring, what's the biggest thing that will go in x squared minus 2x? Take an x out. Once you take 1x out of 2, you got 1 left. Take that x out of minus 2x, you're left with minus 2. So then again, what is common on top and bottom? X minus 4, x minus 2. Now, you might not see it, and you're like, oh, that's 2x over 3x. Now you can cross those x's off because they're not being added or subtracted. That's an old problem. 1 minus 1 is 0. It's gone. So your answer is just 2/3. Last one, I just want to make sure if I gave you 4x squared minus 9 over x plus 5 divided by 2x minus 3. So you want to think of, remember, that's over 1. Sentence division. You're going to flip the second fraction. Top first fraction stays. Reason I wanted to do this is I want you to remember factoring perfect squares being subtracted. Perfect squares being subtracted. Square root, you have a plus and a minus. So that's 2x minus 3, 2x plus 3. X plus 5, nothing. X plus 5. You might want to put it in parentheses because it is a quantity. 1, you don't worry about. If you want to write it, write it. 2x minus 3 is 2x minus 3. That 2x minus 3 would cross off with that 2x minus 3. Your answer, 2x plus 3 over x plus 5. Okay, so you're going to have another delta math assignment that goes along with this video. And then what we'll do for the next day is I have like maybe 12 questions on a PDF. And I'll have you do them, and then you'll be able to ask me questions about specific problems you don't understand in the next couple days. The other thing I want everybody to know on Delta Math, everybody does get different questions. So you can't really collaborate. The worksheets, you're all going to get the same worksheet. But the Delta Math, if write down work while you're doing those. I mean, my own kid was doing them, and he's using a piece of paper. So, and if there's things you don't understand, keep that piece of paper so that you can ask me questions. The examples are turned on for regular college prep algebra 2, so you can see it being done. With honors, I did not do the examples for all types of questions. I think the harder questions, I did turn them on. So hopefully that's not too long, and we'll talk to you soon. Bye-bye.